Okay, ladies and gentlemen, so today we are going to have a look at the properties of some of the different fractions which we can obtain from crude oil. Okay, and the two different compounds we're going to have a look at. First of all is methane, which is the normal gas that comes out of our gas taps here at school. And we're also going to look at a longer chain fraction of paraffin oil. Okay, so on the left we've got the methane from our gas tap, which is a very short hydrocarbon. It's got one carbon in its chain. And then paraffin oil has around 20 carbons in its chain. And we're going to compare the properties of those two things. Okay, so the first key difference that we should be able to notice is that methane, as we know, comes out of our gas taps. It is a gas at room temperature, whereas paraffin oil is, as you can see, a liquid at room temperature. Okay, so clearly there is a difference between their boiling points. Okay, at room temperature, methane has already boiled, which means that it must have a boiling point which is lower than room temperature, which at the moment is about 20 degrees Celsius, so it's got a lower boiling point than that, whereas paraffin oil is still a liquid at room temperature, therefore its boiling point must be higher than room temperature. So we can see already that the longer chain hydrocarbon, the paraffin oil, has a larger boiling point, a higher boiling point than methane. So that's the first property we can see. Okay, longer chains have higher boiling points. Okay. This also relates in to their volatility. Okay, volatility is how easily something becomes a gas. Okay, how much energy you've got to put in to make it become a gas. So methane has quite a low volatility, whereas paraffin oil has a fairly high volatility. Okay, the next one we're going to have a look at is viscosity. Okay, viscosity means how thick the substance is, how gloopy it is compared to how runny it is. So if I take an example, okay, water is not very viscous, it runs quite easily, whereas honey is quite viscous, it's very viscous, it's gloopy, it's sticky, okay, and it all sort of sticks together. So if we look at a gas like methane, if we open our gas tap, okay, is not very viscous. It's not sticking together, it's a gas. The gas particles are all spreading out. Okay, whereas paraffin oil is quite sticky. If I pour it, you should be able to see that it kind of gloopy. Okay, it's thicker than water, okay, and it sticks together quite a lot. So it is more viscous. Okay, and the final property that we need to know is to do with flammability. So let's test their flammability. Okay, so as we're aware, the gas from our gas taps is very flammable. Okay, it sets fire very, very quickly and easily. So high flammability for our low number of carbons, our small carbon chains. Whereas if I do the same thing for paraffin oil, okay, you can see that it just puts the match straight out. I'll go again, bring it a little closer. Okay, so you can see absolutely nothing happens there. So paraffin oil, not very flammable. Okay, so to summarise, we've got our two different chain length hydrocarbons which can be obtained from fractional distillation. On the left, you've got your short chain hydrocarbon, And on the right, you've got your longer chain hydrocarbon. We've seen that longer chain hydrocarbons, the one on the right, has got a higher boiling point because it's a liquid at room temperature. This also means that it is less volatile. It becomes a gas less easily. It's more viscous. It is more likely to stick together and less likely to run if we were to pour it. And it is also less flammable. Okay, so these are the 4 properties of hydrocarbons. You need to know, as the chain gets bigger, what happens to those 4 properties. The boiling point, the volatility, the flammability, and the viscosity, or how viscous it is.